Welcome to Rex. In this video, we'll be learning about how to create a linear regression model using Rex. Linear regression attempts to model the relationship between two continuous variables by fitting a linear equation to observed data. In the model, one variable is the explanatory variable and the other is the dependent variable. Note that in order to create a model, your data must meet the assumptions of linearity, independence, normality, and homogeneity of variance. Let's first take a look at our data. In this dataset, the following data was obtained for 189 mothers and their babies. The baby's weight in grams, the mother's age in years, the mother's weight in pounds, and finally whether or not the mother smoked during pregnancy, where 0 indicates non-smokers and 1 indicates smokers. Let's say we want to analyze the relationship between the baby's weight and these other explanatory variables using a linear regression model. In order to run our analysis, we first select our data, go to Regression, and click Linear. We'll be using this Variable tab to define the dependent and explanatory variables. As we can see, the headings in the first row of the Excel sheet are displayed under All Variables. We can use the arrow buttons to add or remove variables from each option. Let's first select the variable of interest, the baby's weight, as the dependent variable. Next, we will be selecting smoking as our categorical explanatory variable, and then we select mother's age, as well as mother's weight, as the continuous explanatory variables. Lastly, we will click Main Effect to include all 3 explanatory variables as main effects in the model. Next, we go to the Validation tab. In this tab, we decide how to divide the data into training and test data. We will use Rex's default options, which validates the model once by partitioning the data into training and test data. We also will use all data to fit the regression model. Next, we go to the Output tab. In this tab, we will select the statistics, tables, and plots to output. We want to output the confidence interval of the regression coefficient estimates at a confidence level of 0.95. We also want to export the variance influence factors. Next, we want to output an ANOVA table for the regression model. We will use the Type 3 method to calculate the sum of squares for our table. We click Goodness of Fit test to perform a likelihood ratio test that tests whether the current model is statistically different from the null model without explanatory variables. We will also click Residual Diagnostic Plot to output 6 diagnostic plots, including a plot of the residuals against the fitted values. Lastly, we will select Simple Linear Regression to output a regression table of the simple linear regression of each variable. Next, we will go to the Variable Selection tab. We check Variable Selection to automatically select the variable corresponding to the optimal model based on the Akaike information criterion. We then select Stepwise Variable Selection method, which iterates a combination of forward and backward selections. Lastly, the Graph tab can be used to output a nomogram for the model, but today we will choose not to. Once we are done setting up our analysis, we click OK. Once the analysis is complete, a window pops up with the results. Let's take a look at our results. As we can see, the regression results are outputted. Let's first take a look at the coefficient estimates from a regression. The sign of each coefficient indicates the direction of the relationship between the explanatory and dependent variables. The value itself represents the mean change in the dependent variable given a 1-unit change in the explanatory variable. Let's take a look at the regression coefficient for the mother's age. Here, the coefficient is 7.1538. This means that the model estimates that the baby's weight increased 7.1538 grams on average for every year increase in the mother's age. On the other hand, if we look at the smoking variable, the coefficient is negative 269.2570. This means that the model estimates that the baby's weight decreased 269.2570 grams on average for mothers who smoked versus mothers who did not smoke. Next, let's look at the p-values. We can use these values to verify whether the estimates are statistically significant. The p-value for each term tests the null hypothesis that the coefficient is equal to 0, as in the explanatory variable has no effect on the dependent variable. At a 95% confidence level, a p-value less than 0.05 indicates that you can reject this null hypothesis. Here we can see that the p-value is less than 0.05 for the effect of smoking and the mother's weight. This indicates that the effect of these variables are statistically significant. On the other hand, p-value is greater than 0.05 for the effect of the mother's age. This indicates that the effect of this variable is not statistically significant. Lastly, let's take a look at the variance influence factors. These values are indicators for diagnosing the multicollinearity of explanatory variables. In general, a VIF above 10 indicates high correlation and is a cause for concern. As we see, the VIF is less than 10 for all explanatory variables, indicating that there is no to low multicollinearity. The ANOVA table indicates whether the regression model is statistically significant and how well the model fits the data. As we can see, the p-value is less than 0.05, indicating that the model is statistically significant. The R-squared, also known as the coefficient of determination, is a goodness of fit measure for linear regression models. For this model, the R-squared is 0.0704, indicating that the model explains around 7% of the variation of the dependent variable. We can use the regression diagnostic plots to check whether three assumptions, normality, independence of observations, and homogeneity of variance, are met for the dependent variable. For example, if we take a look at our QQ plot, these data form a pretty straight line. This tells us that our residuals are approximately normally distributed. Lastly, the regression coefficients of the model and the ANOVA table are outputted together at the way end. Overall, as we have seen in this video, the linear regression model helps us analyze the linear relationship between a dependent and explanatory variable. Thank you for watching today's video in statistical analysis in Rex Pro. Don't forget to like and subscribe to RexSoft's YouTube channel for more informational videos on statistics, data, and how to use Rex.